We have added vectors together graphically. Today we're going to learn how to do it analytically because now we know how to find the x and the y components of vectors. And so now we're able to add them together in a mathematical sense and not just get something approximate from sketching it on a graph. I'm going to work through the second part of example 3.5. It says, following the directions on a map, a Girl Scout walks 3.2 miles at 130 degrees. She then turns and walks 2.3 miles at 40 degrees. What is her final position relative to her starting point? And I didn't get the proper number of significant figures on there, so we'll fix that. The first thing that you should do when you're working a problem like this is just make a quick sketch. Now, I'm not talking about getting your ruler out and getting your protractor out and doing it so it's all exact. That's not what I mean. What I mean is just to do a really quick sketch so that you know what neighborhood your final answer should be in to make sure you haven't made some sort of mistake. So, these vectors are, this one's going to be, about 2/3 the length of this one. And so if this is 3.2 miles at 130 degrees, my first vector is going to be, so this is 90, it's going to take another 40 degrees this way, so it's going to be about there, okay? Then she turns and she goes 2.3 miles at 40 degrees. Okay, well remember, that's always from what the x-axis is. So if I drew, just to help me see it, if I drew another coordinate system there, 40 degrees is going to be about here, and it's not going to be quite as long. It's probably going to be maybe about there. Okay, so that's the direction that she's walked. What's the resultant vector going to look like? Well, it's going to be up in this neighborhood someplace. Okay, so it's going to be pretty well close to straight up. Again, I did not do a lot of measuring. I didn't measure my angles exactly. So I'm not going to be surprised if it ends up in this quadrant or if it ends up in this quadrant. I can't tell exactly where it's going to end up. Probably it's going to be in this one, but it's going to be really, really close. But this resultant vector should be up in this direction. Okay, so you want to do that real quick so that you know that your final answer is reasonable when you finally come up with one. Okay, now I'm going to show you how to set this up in a way that I think is the easiest. You don't have to do it this way, but I think it's a little easier to do it this way. So if I have my 3.2 miles at 130 degrees, and then I have 2.3 miles at 40 degrees. What I'm going to do is I'm going to calculate this. So I'm going to put my x component here, and I'm going to put my y component over here. I'm going to almost kind of like make a table. So we learned the other day that to find the x component, you need to take the cosine of the angle. So this is going to be 3.2 miles times the cosine of 130. And this one is going to be 2.3 miles times the cosine of 40 degrees. We also learned that the y component is going to be the length of the vector, 3.2 miles, times the sine of the angle, which would be 130 degrees. And that means this one is going to be 2.3 miles times the sine of 40 degrees. Okay, so you can kind of see how I've got it set up kind of as a table. And so then I'm going to take my calculator and I'm going to calculate all of those. And to save us some time, I have already done this. So this is going to be a negative 2.1 miles. And this is going to be a positive 2.5 miles. And be thinking the whole time, does that make sense? Well, this vector here, this is the first one, was going off in this direction, so it would make sense that the x component is negative and the y component is positive. Then when I look at the second vector, this one comes out to be 1.8 miles, and this one comes out to be 1.5 miles, so both of these are positive. Well, originally, if I would have started this vector down at the origin, it would have been here, and so in this quadrant, both components should have been positive, so that makes sense. Okay, so far everything looks good, my answers are making sense. Now, what we have to do is we have to add the x components together and the y components together. So if I add together, and when we talk about significant figures here, this one is going to have two significant figures, and this one will have two significant figures also, because I don't have any more in any of these spots. So all these have two. So when I add these together, I have a negative 2.1 and a positive 1.8. So that gives me a negative 0.3 miles for the x component. And then I'm going to have 4.0 miles for the y component. Does that make sense with what I thought I would have? Well, negative 0.3 is not very far over this way at all. And then 4 miles is going to put me up here. So the answer, again, that I got makes sense with the vector that I sketched. It is a logical answer. So now what I want to do is I want to calculate the magnitude of that resultant vector. So the magnitude, I used the Pythagorean theorem for that. So I'm going to have negative 0.3 miles squared plus 4.0 miles squared. And then when I take the square root of that, you should end up with 4.0 miles. Significant figures, 10th place here, 10th place here, so I'll have the 10th place in my answer. I mean, that makes sense. I didn't go very far over, so that's logical to the correct number of significant figures. I told you that this one should be bigger than both of these, but this is so little that by the time I start squaring things, 0.3 times 0.3 is 0.09. It's tiny, and when you add that to 16, it doesn't make much of a difference, okay? So then to find theta, theta is going to be the inverse tangent of the y coordinate, which is 4.0 miles, over the x coordinate, which is a negative 0.3 miles. And so when you calculate all that out, you should end up, we're only going to have one significant figure, and so I end up with a negative 90 degrees. Now, remember, we have to check about the quadrant that this is in, and so if the x component is negative, the y component is positive, that means that I'm over here in the second quadrant. I'm not there by much, but I'm still over that y-axis, so I'm still there. So that means in order to get this in the right, so that I have the right angle degree, I'm going to have to add 180 degrees to that. And so I should end up with 90 degrees. So my final vector answer then is going to be 4.0 miles at 90 degrees. Okay, so that's the final answer to that problem. I realize that that may look very complex, but let's go back and let's say, okay, let's break this down so that it doesn't look so bad. First thing you're going to do, draw a real quick sketch to see what the final answer should look like. Then you're going to break the two vectors that you were given down into their x and y components. Once you have those components, you're going to add the x components together. You're going to add the y components together to get the resultant x and y components. Then you're going to do what we've done before. You're going to use the Pythagorean theorem to find the magnitude. You're going to use the inverse tangent to find the angle. And so that's going to be your final answer. So while it certainly looks like a whole lot of work to get there, none of the steps are difficult. It's just a little bit time consuming in order to get to that final answer.